This lesson is for FST lesson 7.3 on division and on the remainder theorem. We're going to do some review on long division, so there's some vocabulary we need to begin with. Keep in mind that fraction problems are division problems. The top number is referred to as the dividend, bottom number by the divisor. The way that I try to remember those is the thing that's being divided is the dividend, so they both start and end with the letter D, divided and dividend. And it's being divided by the divisor. The divisor, when you set it up as a long division problem, is going to be out front. The dividend, the thing that you're dividing, is going to go underneath the bar. Your answer after you've divided is referred to as the quotient. Keep in mind that if there is a remainder, you need to show what that remainder is right next to the quotient itself. So we're going to do review of long division in general. And then we're going to get into long division of polynomials, which is our main focus for the lesson. I tried to use color here to help students visualize the different steps. If you were working with a fraction and asked to divide 987 divided by 26 with just a baby calculator, you would set it up as dividend under the bar, 26 the divisor in front. You would not need to divide 26 into the entire number, you could just do 2 digits at a time. So I'm going to ignore the 7 temporarily, and I'm going to ask myself how many times I think 26 goes into 98. So if I kind of do some estimating here, 25 goes into 100 4 times. So I'm going to estimate that as being a little bit lower than that. Since it's not 100, it's a 98. So I'm going to use a 3 there. So I put the 3 above the 8 to line up my division. Now I'm going to multiply the number that I chose by the 26. And you could use a calculator for that if you didn't know. So I got 78. Obviously I didn't get to 98 exactly, I got close to it, so I want to see how close I got. So after you multiply, you're going to subtract to see what's left over. After you've done that, now you're going to bring down any remaining digits so that you can start dividing all over again. Keep in mind that usually you'll only bring down one thing at a time. If there are other digits there, you can bring them down, but know that you may or may not use them. Usually we only bring down one thing at a time. So now the problem starts all over again. It's almost like we're now going to perform division of these two numbers. How many times does 26 go into 207? Now if you're not sure, a good rule of thumb is to start with the number 5 and then you can either go up or go down from there. So oftentimes I'm doing long division with a pencil because I often make mistakes. I don't necessarily guess on the first try correctly. So I think on this one I tried 6 first and that wasn't big enough, so I ended up going to 7. So I think this answer is actually my final draft. I think there was a rough draft here that I'm not going to reveal. So I ended up with a 7. 7 times 26 is 182, which is as close as I could get to the 207. There was 25 left over. Because what I got left over was smaller than the thing that I'm dividing by, and because there's no other numbers to bring down, I know that I'm finished. Since I didn't get a 0, I know that that 25 is my remainder. So I write the remainder up at the top and I divide by whatever the divisor was. So then my final answer here is 37 plus 25/26. So that's my final number. Our focus today, however, is going to be to use those steps that I indicated here, to divide polynomials. And I think for students that may or may not be easier than doing the long division here. So when you're doing division of polynomials, you're only going to deal with the first term in each piece. So we're going to say to ourselves, x times what is 2x squared? If it's easier for you, do the numbers and then the letters. So 1 times what is 2? That's got to be a 2. X times what is x squared? That's got to be an x. So I ended up with a 2x as my answer. Line up your answer with anything that it's a like term with. So I'm going to put the 2x up top. So just a quick review there on how I got that again. I did x times what is 2x squared. So I'm not going to use the 4 right now. I'm only using the beginning there and the beginning there. First term here, first term there. Now I do second step, which is to multiply. When you multiply, you're essentially taking that number and you're multiplying it by the divisor. Keep in mind that you're going to use both pieces of the divisor this time. So we have to do 2x times x and 2x times negative 4. Now we're going to subtract what we got. Keep in mind that when you're subtracting, you have to subtract both pieces. So I often tell kids, After you're done multiplying, put what you got in parentheses and put a very large subtraction symbol in front to remind you to make sure that you're subtracting all the parts. Now if you did this number up top correctly, and if you multiplied correctly, the first two numbers should cancel automatically. If they don't, you should backtrack and figure out where you goofed. Now when we subtract, just make sure, usually the second number is the number that throws kids off. We have negative 5x minus negative 8x. And the toughest part for students there is remembering that you have to add the opposite. So that ends up being positive 3x. Now we're going to bring down, making sure to bring down the symbol with the number. So now it's almost like I'm starting all over again. I'm doing x minus 4, and I'm dividing it into 3x minus 12. I'm only going to worry about the first term in each. X times what is 3x? That's just a 3. Keep in mind that that's a positive 3, so I do need to put a plus there. Otherwise it's going to look naked. 3 times x is 3x. 3 times negative 4 is negative 12. Now when I subtract, I do indeed get a 0, which means I'm finished and that there's no remainder. So my final answer then is 2x plus 3. Keep in mind that if I did 2x plus 3 times the original divisor, I would get the polynomial that I was dividing back. So what's nice about division here is if you end up with a 0 remainder, you can double check your answer by doing FOIL, and you should get that polynomial back. So let's try that again with two other situations that students might run into. First of all, when you're working with a problem, there may be instances where there are pieces missing. Remember, when you do things in standard form, usually there's all the pieces represented. Like here we've got x squared, the next piece should be something x, or x to the 1, and then the constants at the end. But this one's missing that piece, so we should rewrite it with a 0x there to help us hold the place. Same thing's occurring here. We've got an x to the 4, x to the 3rd, the next piece should be x squared. And without that, that may make it difficult for us to line up our answer. So before you start any problem, make sure that there are no missing terms, and go ahead and fill those in with zeros. So now we're going to go ahead and just practice division again on this one. Again, you're only going to focus on the first term of each piece when you start. 2 times what is 8? 4. So I'm just going to remember that number off to the side. X squared times what is x to the 4th? X squared. So that's my first term, and I'm going to line that up with whatever it's a like term with. And right away you see that without that x squared it would be hard to know where to put that answer. So it's nice to have that as a placeholder. Now we multiply. 4x squared times 2x squared. 4 times 2 is 8. X squared times x squared is x to the 4. Keep going. 4x squared times 0x is 0. 4x squared times 1 is positive 4x squared. Now I'm going to subtract. Big subtraction sign. 8x to the 4th minus itself is nothing. Negative 2x squared minus nothing is negative 2x cubed. Excuse me, that should have been a cubed. And 0 minus 4x squared is going to be negative 4x squared. That's a common spot for kids to goof up. They see a plus there, and so they think it just drops down because there's a 0 above it. But it's 0 minus 4. That has to be a negative. Since my original divisor is a trinomial, we do need to bring down the next term here. It's not wrong to bring down the negative 6, but you don't need it right now, so we'll bring it down later. If you did bring it down, you'd still get full credit. So now we're starting over. 2x squared times what is negative 2x cubed? 2 times what is negative 2? Negative 1. X squared times what is x cubed? Just x. If you don't want to write the negative 1 there, you don't have to, but you do need to have a negative symbol there at a minimum. Now you multiply. Negative x times 2x squared is negative 2x cubed. Negative x times 0 is 0, so that's going to leave an empty space. Negative x times 1 is negative x. Now I'm going to subtract vertically. The negative 2x cubes are going to cancel. The negative 4x squared drops. Negative 3 minus negative 1. If I add the opposite there, I'm going to get negative 2x. Now I'm going to start all over for the last time. 2x squared times what is negative 4x squared? I know that's going to be a negative 2. No x's because I've got square and that's what I need. Now I multiply. Negative 2 times 2x squared is negative 4x squared. Negative 2 times 0 is 0. Negative 2 times 1 is negative 1. Now look what I did. I forgot to bring down my negative 6, didn't I? Did you catch that? So I should have brought down my negative 6 here because I needed a trinomial. I would have caught it now when I did 1 times negative 2 and there was nothing to line it up with. Now when I subtract, those are going to cancel. The negative 2x drops down. Negative 6 minus negative 2. Add the opposite, we get negative 4. I know I'm going to quit now because first, there's nothing else to bring down, and negative 2x is technically smaller than 2x squared. A square is always bigger than a plain x. So that's my remainder. So I need to add it back up to the answer, and I need to make sure to include that it gets divided by the divisor as well. If you want to ignore the 0 part of it, you may, and just say plus 1 there. If you wanted to just say minus 2x squared at the top, minus 2x at the top, that's perfectly fine too. I just put it as plus negative. So then my final answer is here. So students will get the chance to practice a question like that in the homework. Our last topic for today is the remainder theorem. The remainder theorem will be on your next test. So make sure it's something that you know how to use and apply. It says that if a polynomial, p of x, is divided by x plus or minus a number, then the remainder is p of that number. Keep in mind that when it's x minus, you're going to plug in c. If it were x plus c, then you'd plug in negative c. So it's always going to be the opposite of whatever that factor is. Keep in mind that we could not use the remainder theorem on the problem we just did, because the divisor wasn't just an x plus or minus a number. It was a 2 with an x in front of it, a 2 with an x next to it, and it also has a square. So if it was an x plus or minus a 1, then we could have used the remainder theorem, but it's not, so we can't. So only in those instances will the remainder theorem help you. The remainder theorem is a shortcut. It's a way of finding the remainder without having to do the full division. So let's try it with this example. Since I'm dividing by just a plain x plus or minus a number, I'm going to fill in that number into the polynomial, and I'm going to calculate. Keep in mind here, are we going to fill in a 5 or a negative 5? Yes, we're going to fill in a 5. So I'm going to say 4 times 5 to the 5th minus 5 cubed plus 1. If it was x plus 5, I would have filled in a negative 5. Since it's a minus 5, I'm filling in a positive. When you calculate that using the order of operations, you get 12,376. Really nice shortcut. All I had to do was find the remainder. I did not need to set up a division problem in order to find it. I could have, but it would have been a lot more work and it would have been unnecessary. I don't need to divide to find the remainder if the factor that I'm dividing by is just x plus or minus a number. So keep in mind that you don't always have to do division. I'd like students to try number 7 right now. It says, use the remainder theorem to find the remainder when the first polynomial is divided by the second. Here's the first, here's the second. So your very first thing you're going to do is not divide, but find the remainder, and then you're going to set it up as a division problem. Keep in mind, students, that you need to figure out how to set it up if you're doing first divided by second. Pause the video and give those both a try. Answers will be displayed shortly. First off, you're going to fill in a negative 3 because the factor is y plus 3, so you're going to fill in negative 3 for y. It's always the opposite of whatever that factor is. When you calculate it, you get negative 13. When you do the division, it's going to look like that. Keep in mind that this one's a little tricky because when you do your first step, both pieces become 0, so you have to drop down 2 things this time. The reason why you do that is because you have a binomial out here that you're dividing by, so you need a binomial here as well. So know that you will have to drop 2 pieces in this step. Notice that we did get the remainder that we were expecting to get because of the remainder theorem.